Hello everyone, welcome to Code and Learn. In this video, we are going to look at a problem of integer multiplication. We will be given two arrays representing integers and we need to return an integer representing their products in array form. As you know, in any programming language, the integer value or the int data type has a max value that you can store in it. If you go beyond that value, there will be a data overflow and you will get errors. So this is a useful algorithm to perform multiplication of integers represented by arrays. So there's no limit for the max integer value that you can store in arrays, since arrays can be of any length. This is how you will be given an integer value. That is, as you can see, 100 is represented with an array where the value at 0 index is the MSB, that is 1, followed by 0 and 0. So the last element is the LSB while the first element is the MSB. Similar to that, we have another example which is 127, which is represented as elements 1 to 7 in an array where the most significant bit is stored at index 0 and the least significant bit is stored at index 2. So to recap, we will be provided integer values like this and we need to perform multiplication and return the result. So to develop the algorithm that can be used to perform this multiplication, we will look at how we perform multiplication in school or in elementary school. Here I have two numbers, 15 multiplied by 14. Now to perform multiplication, what you will do is first multiply 4 by 5, that is 20. Then 2 is taken as carry. So you are keeping the LSB or the least significant bit and moving the MSB as a carry. Then you perform the next multiplication, that is 4 into 1, 4 plus 2 of the carry and 6. Then we move on to the next number. 1 multiplied by 5 is 5 and 1 multiplied by 1 is 1. In the end, we are going to add it and our result will be 210. You can understand a pattern here. That is, we are going through both the integers digit by digit and multiplying each digit with every other digit. So something like this. Intuitively, this could be replicated with a loop inside another loop. Now it's time to visualize the solution. We are going to replicate the elementary school multiplication. First, we will create an array to store the results. The array length would be number of digits in the first number plus the number of digits in the second number, because that is the maximum number of digits that can be there in the product. First thing we do is store the result of the multiplication, that is AI into BJ. So let's represent the first number or 15 by I. This is 0 index and this is 1. Then the second number by J. This is 0 index and this is 1. In our high school multiplication, we start from the MSB. That is, we will start from index 5. So we say 4 into 5 is 20. We store the result 20. Now the next thing we do is move the MSB to the left. For that, we use division. So 20 divided by 10 would be 2. We move it to the left, that is 2 here. And then the next step is to only store the LSB, that is 0 here. So this is what we get for our first iteration. Now let's move on to the next digit, that is 0 in I and 1 in J, or the second number. Let me mark the index here. So this is 0, this is 1, this is 2, this is 3. So the product is 1 into 4, that is 4. If you notice, we are doing a addition here. So that will act as a addition of carry. That means 4 will be added to the index value at 2. So we will have 6 here. Let's update it to say 6. Now we move on to multiplying 1 with every digit in first number. This time I is 1 and J is 0. So 1 into 5 is 5. That is, we are going to add it here, similar to how we added the carry. So this becomes 11. Then we perform the next step, that is moving the MSB to the left. So 1 will get here and the value that remains here is 1. In the next iteration, we multiply 1 by 1. That is, we will store the result as addition to here. That is, this is modified to be 2 now, which is our result. Nothing will happen with these two steps because we don't have any MSB or LSB to transfer. As such, we will get our result. Try to visualize it. This is very similar to how we did the multiplication using the elementary school method. Now let's look at the code. I'm simply going to call the function multiply. It's going to take a and b, which are both integer arrays or integer slices, and go. And as a result, we return another integer slice which stores the product. First thing we need to check is for edge cases, that is, if any of the number is 0. If len a is equal to 0 or len b is equal to 0, return a empty slice, that is int. Now one thing we didn't take into consideration when looking at the visual representation of this solution was to store the sign. That is something we are going to do here. Let's create a variable to track it. Sign is 1, that is positive. Then I check if most significant bit of a is less than 0, that means the sign is negative, or sign multiply is equal to -1. Now since we have stored the sign, we can set a0 to a positive value, that is multiply it with -1. Similar thing we will do with b. If the most significant bit of b is negative, then we multiply the sign with -1 and then set the value of the most significant bit to a positive value. This way, if both the numbers are negative, they will cross out each other and sign will be positive. Now to store the result, we are going to initialize a slice. So I can say result int slice. Length of this will be length of a plus length of b, which is the maximum number of digits you can have in a product. Next up, we will start a loop to multiply each digit from a with each digit from b. We are going to start from the back, that is from the least significant bit. So I can say for I is equal to len a minus 1, I greater than is equal to 0, I minus minus. Inside it, we will have another loop which is very similar, that is j len b minus 1, j greater than equal to 0, j minus minus. Inside it, we will perform the 3 steps, that is first store the result I plus j plus 1. Please notice we are going to add it to any already existing result. So this will replicate the carryover behavior, ai into bi. Then we will have add msb to the place to the left. So perform the carry. Result I plus j is plus equal to result I plus I divided by 10. Now the third step is to just keep the LSB at the current position. So keep the LSB or the least significant bit. Then we do result I plus j plus 1 modulo equal 10. Now this loop will perform our multiplication. Now we need to account for the sign. So what we will just do is multiply the most significant bit with the sign we stored earlier. So we can say sign and in the end return the result. So that's the code solution for it. Just to recap, first thing we did was to check for edge case and return an empty slice for when any number is 0 or empty slice. Then we stored the sign followed by creating a result array that we will use to store the result. Inside a for loop, we perform the multiplication and store the result. At the end, we just restore the sign and return the result. Now let us look at the time and space complexity. The time complexity of this solution is O of n into m, where n is equal to the number of elements in A and m is equal to the number of elements in B. This is because, as we already covered, we are going to multiply each digit in number A with each digit in number B. So we had to use a loop inside a loop. To compute our solution, we are not using any extra space, so the space complexity is O of 1. You can argue the result that we store is using a new slice, so the space complexity could be O of n plus m, which is correct. As such, I wanted to mention it here. That's it for this solution. I hope you enjoyed it. If you have any questions, please post a comment under the video or reach out to our Discord server. Until next time, happy coding.